Okay, I'm glad to introduce Professor Sylvia Osborn from the Department of Computer Sciences at the University of Western Ontario. Professor Osborn has done a lot of influential research in the area of role-based access control and database security.
Okay, thank you very much, Elisa, and good afternoon, everyone. So the outline of my talk today is I'll spend a fair bit of time talking about the role graph model, which is our version of role-based access control, or RBAC, and the differences between our model and the NIST ANSI standard model. And then I'll look at, again, mapping from discretionary access control to roles, and then I'll have a few comments about delegation and a few comments about the future of RBAC. So the beginning of role-based access control, actually, if you Google role-based access control, you'll come up with 3 papers from the 1980s. And some of these papers actually have all the concepts there, but people didn't really pay much attention to it. This tends to happen in I think in computer science research, good ideas get reinvented every 10 or 15 years. And then if you move into the early 90s, we see some early papers by Ferriolo and Kuhn from NIST. My PhD student, Matunda Nyanchama, and I, and Ravi Sandhu and some of his colleagues. And these are the real important introductions to RBAC, which have carried on. The earlier papers, the ideas sort of got overlooked. Okay, so what is our role graph model? So as Nyanchama envisioned it right at the beginning, he talked about it being on 3 planes. So we'll start with the middle, and in the middle we have the role graph or role hierarchy. A role is defined as it has a name and a set of privileges or permissions. Some people say permissions, some people say privileges. It means the same thing. A privilege is a object access mode pair, and we have edges in the role graph whenever we consider one of the roles to be junior to another role. It means all of the privileges of the junior role are contained in the senior role. And we actually distinguish between direct privileges, which are those that are assigned to a role by the administrator of the system, and the effective privileges, which includes the direct and all the inherited privileges. Privileges, again, consist of an access mode object pair. Both of these components can have some kind of structure. So the object could be a big complex automobile design in an object-oriented database. It could be a single value in a relational table. It could be an XML document. And there was some early work on object-oriented database security by Elisa and some of her colleagues, where they examined how permissions can propagate either because of the access mode or because of the object structure. And so if you think of an XML document, it's basically a tree. And if you have a permission, say, to read that starts partway down, so this thing here is meant to represent an XML document. If your permission to read starts here, it would propagate to all the sub-elements in the XML document. Now on the left-hand plane, we have something we call the group graph. And we define a group as a collection of users, full stop. And so you can create groups just because it's handy to have them to assign to roles. So here in this example, we have this admissions committee. It has some university employees and it has a student. And they're on that committee because they belong, for whatever reason in the real world. And if we represent that as a group, then we can assign it in one operation to all the permissions of the admissions role over here. So we haven't actually drawn the user role assignments on this picture. And then So I've talked about the three planes, and so then we have the relationship between privileges and roles, which gives you the privilege role assignment and the user role assignment. And you can also create groups, maybe according to some qualifications that people have. So you might have a group for accountants, and the basis of belonging to that group is just that that you have, the appropriate qualifications, and it has nothing to do with anything that you're actually performing at the moment. It just has to do with you as a user. Okay, so again, very early on, we started talking about algorithms, and we ended up with two role insertion algorithms. The first one was the one that Matunda had originally, and the parameters are that you have a given role with its name, its direct privileges, the other roles that you expect to be its juniors, and the roles that you expect to be its seniors. We require that the role graph be acyclic. So in all of our algorithms, if we're about to create a cycle, we just abort and return to the previous version of the graph. And when we're done with the algorithms, we clean up. So you may have thought something was a direct privilege, but by specifying a junior, it ends up being an inherited privilege. And so we change the representation of the privilege. And we actually insert extra edges if we discover that there are two roles in the graph such that one of them permissions are a proper subset of the other one. And I'll try and explain why we did that in a minute when we look at an example. So if you're going to have duplicate roles, this will oblige you to create a cycle which violates it being acyclic. So basically we don't allow roles with duplicate privilege sets. And in the second role insertion algorithm, you just give the role with its effective privileges, and the algorithm does all the work for you. It figures out where it belongs in the graph and where the edges go. All right, so here's an example of the first algorithm. So we want to add an instructor role, and the result of that is, so we've thought that counselor will be a junior, and we've thought that admissions would be a senior. And so the algorithm draws the brown edges that are there. Sorry, the brown edges are given. The algorithm also notices that, so what I've shown here is the role name and the effective privileges I've just represented by numbers. So the instructor has permissions 1, 2, and 3, which is a proper subset of the privileges of the dean role. And so we draw an edge there. And why do we do that? Well, we decided right at the very beginning that because the dean role contains all the privileges of the instructor role, we should show you that by inserting this role, if you assign someone to the dean role, they can effectively perform the instructor role. So why not give that as feedback to the user who's designing the role graph? And this has consequences, as we'll see later. And it's really the main way in which we differ from the ANSI model. Now, if we want to start with the original graph again and insert a role senior counselor with 3, 5, 6 as direct, counselor as junior, we end up inheriting 1, 2, which gives us the same privilege set as the dean. And so we would reject this operation because it creates a duplicate role. And we would be obliged to insert the edges that would create a cycle, and then it wouldn't be acyclic. An example of the second role insertion algorithm. You just give the effective permissions, and the algorithm figures out where it goes in the graph. This is the one actually that people prefer to use because it's a little less work. Okay. So we have other algorithms, insertion and deletion of a privilege to or from a role, adding and deleting edges. I also did a little piece of work on merging two role graphs, so vaguely related to database integration. So suppose you're integrating two databases.